Section 2.5, Reasoning in Algebra and Geometry. What we're going to try to do is connect reasoning and algebra and geometry together. These are the properties on page 113 that I wanted you to copy. You can have the entire table if you want to. Both sides, so you can do this whole entire thing. When we look at properties of equality, they're not really postulates, they're not really theorems, but they are used as reasons, and that's why I want you guys to put them back there. For some of you, if you know that the addition property means that you add the same thing to both sides, you may not need that right column, okay? If you know what it stands for, you don't need to necessarily copy this part right here. Okay, you could just do maybe the left side and do the names. However, the three that maybe you aren't as familiar with are the reflexive, symmetric, and transitive properties. Those you might want to do the entire thing if you're not fully aware of what they look like. So you can do the entire table, but the ones that I want you to for sure get down both sides would be the three that I just circled, reflexive, symmetric, and transitive. So here's what they mean. The addition property of equality means that you add the same amount to both sides. So when you look at this right-hand column, the plus C just means you're adding the same amount to both sides, okay? The subtraction property means that you're subtracting the same quantity from both sides. Multiplication means you're multiplying the same quantity to both sides. Division, same thing, you're dividing both sides by the same number. So those kind of make sense because you've learned them, you've already, seen them before. The three that maybe you haven't seen as often are reflexive, symmetric, and transitive. These are used in proof a lot, so make sure that you have them in there. Reflexive property, this one looks kind of silly, but when we start doing them, this will be one of those properties that you know because it's one that's really easy to spot. It just says A equals A. When the left side is the exact same thing as the right side, it's reflexive. And I'll point this out again, probably quite a few times, what it looks like. For now, it probably won't make any sense to you because we haven't done anything with it yet. Symmetric property, when you look at it, you start with A equals B and you flip it over. So basically, the right side becomes the left side becomes the right side. It just means flip it over. Transitive, if A equals B and B equals C, that's what you're given. Notice how the two B's in the middle are the same. Well, if those two are the same, the other parts have to be the same as well. So then A is equal to C. We'll look at transitive a lot, probably often today as well. And then substitution, when you replace something with a number or a letter. Also, when you guys look at the notes on the computer, notice how my writing stayed here. If you're just looking at them online and it's doing that, somebody said if you download them, it fixes them and puts them in the right spot. It also means that if you download them, it's saved to your computer though, so it's taking up space on your computer, but somebody said that if you download the notes, it takes care of stuff like this that just happened on my screen. So I'm going to erase it here. I'm not sure if it erased it there too, probably, but at least we don't have to look at the writing over top of the writing. Algebraic properties of equality are used in geometry that'll help you solve problems and justify each step you take. In geometry, postulates and properties are accepted as true, so you won't ever have to prove any of these properties. They're accepted as true just like they are. The theorems are the things that we normally have to prove and other things that are using those. For the distributive property, you can write the entire thing if you want to. The only thing you probably will have to write is probably those, and that would give you kind of an example of what distributive property looks like. If you have something sitting on the outside of a parenthesis, you want to distribute it to each member on the inside of the parentheses, and you still end up with that same number of terms. Most people are pretty familiar with distributive property. You can do that with adding or subtracting. And then we get to properties of congruence. You can do this entire table as well. I'm going to go back up and say copy. The only thing will be is that these have, properties ahead of them instead of postulates and theorems, which it really doesn't matter. Reflexive property, again, we just went through the reflexive property. Whatever's on the left is the same as it is on the right. So that one kind of looks the same. Symmetric property means whatever's on the left, you just take it and you flip it over. So here on this one, AB is on the left. When you flip it over, it flips, and it's on the right. Transitive property, they have it listed in a variety of different ways. Notice for each one of them, where you see this and, the item ahead of it and behind it are the same, so that that first item equals the last one. And that one we'll look at numerous times, so eventually, if it doesn't make sense today, it will. You use deductive reasoning when you solve an equation. You can justify each step with a postulate, a property, or a definition. And that's what we're going to do next. What's the name of the property of equality or congruence that justifies going from the first statement to the second one? So what you guys are going to do is, if you were solving this equation right here, what would be the first thing that you do? The 2x plus 9 equals 19. How do you solve for x? Do what? Okay, so you are using the subtraction property. So if you think in your head, what do I do to solve this? And you're going to write minus 9 minus 9. That tells you what property you're using because you are subtracting. So your answer would be subtraction property of equality because there's an equals in here. Sometimes or eventually we're going to hit where there's a congruent symbol in there. And then there's going to be properties of congruence too. So for now, make sure you put that equals at the end because it is important to get used to doing that now so that when we have something else different later, it's there. So what are you doing to go from the first one to the second one? That's the property that we're using. Here's another one. If angle O is congruent to angle W and angle W is congruent to angle L, then angle O is congruent to angle L. This is one of those that we're starting with the first line and ending with the second one. Notice how these in the middle kind of disappear. That's transitive. So if the two things in the middle are the same, the other two things have to be the same as well, and that's transitive property. Is it equals this time? No, that's a congruent symbol, so I'm going to put of congruence at the end. So whatever symbol you have is basically the symbol that you're going to use in your answer as well. So this one would be the transitive property of congruence. And I'm just going to kind of use arrows to show you that those two things are equal. How about this one? Measure of angle E equals measure of angle T. That's what you're given. They're saying, how do they go from measure of angle T to measure of angle E? What are they doing on that one? Flipping it over. Which property was that again? Reflexive is the same. What was the next one? Symmetric. Yep. So when they take it and they just go like this and just flip it over, that's symmetric property. And you can abbreviate it SYM if you want to. And it has an equals in there, so I'm going to put symmetric property of equality. If you don't want to write out of equality every time, just throw a little equal symbol in there and we'll call it good. Eventually, they'll have a congruence in there. And some of these you just have to look at a few times and you're going to know them. So symmetric is usually pretty easy to spot. Transitive is easy to spot, and so is reflexive. But reflexive just seems weird when they put the same thing on the left as they do on the right. What's this one? Segment AR is congruent to segment TY. And then they go to segment TY is congruent to segment AR. What have they done? flipped it over just like they did the last time. The only difference is there's a congruent symbol this time. So I'm going to say again, symmetric property of congruence. Now, when we start solving equations, that's when people kind of have trouble. Some get it right away. Some are like, I don't get where I put the reason. Is it on the one or the next one or whatever? So we're going to get to that here in a minute. What did they do on this one? 3 parentheses x plus 5 equals 9, and they went to 3x plus 15 equals 9. What property is that? When they take the 3 and they multiply it through, what's that called? Nope. Distributive property, yep. And it does have an equals in there. Distributive property is probably the only one that I'll let you not put the symbol on, like the equals are congruent, because distributive property works in either one. So I'm going to go, if you put an equals in there, that's fine, but I probably wouldn't count it wrong here. So when they take the parentheses out, they're using the distributive property. How about this one? 1/4 x equals 7. That's where they start, and they went to x equals 28. How did they get rid of that 1/4? They probably multiplied. I would accept one other one. What would be the other one? Division. Yep. So here they're saying probably multiplication property. So they're multiplying each side by 4. Multiplication property of equality. I'm going to put or division property. If they did division, they would be dividing by 1/4 both sides, but you can do either one here. The book, I think, will usually go multiplication, but I would accept both. Okay, here's where we start looking at what is a proof and what does it look like. A proof is a convincing argument that uses deductive reasoning. It logically shows why a conjecture is true. So here's where people are like, oh my gosh, this is where we start proofs. I've heard horror stories about these. The first ones that we do are not so bad. A lot of the ones that we get to that are geometric in nature are harder because we haven't worked with geometry as long. But I try to make them easier by giving you partial proofs is what I call them. If it's a 2-column proof, I fill some of it in and you guys have to fill in the rest. So you wouldn't have to start from the very beginning and get to the very end on your own, because guess what? We don't know how to do these. We're not good at these right away because we haven't ever done them before. So I try to kind of gradually go into it instead of going, yep, you're on your own now, you have to know everything. That's what makes proofs hard, is that you're expected to know every single thing we've learned so far. And if you don't remember it and you don't have a reason, you can't write it down. So many of us still are kind of have a lot of reasons and a lot of things filtering through our head. You got to kind of have them in your head in order to be good at them. So we're going to gradually go into them, and hopefully that'll be something that works for everyone. A proof is a convincing argument that uses deductive reasoning again. It logically shows why a conjecture is true. A 2-column proof lists each statement on the left and its justification on the right. So remember when I said you have to know everything that we've learned so far? The reason is on the left, or the statement is on the left, the reason is on the right. I like the 2-column version because it's easy to do, easier, and it's easier for me to correct. When you talk about the different kinds of proofs, there's a paragraph proof. Those are harder because you can use your own words but still say the same thing as mine. When you look at doing that, it just takes longer to do. Many people are not as good at paragraph proofs just because we haven't even done the 2-column ones yet. So I like to focus on 2 columns. You can always do a 2-column proof and turn it into a paragraph proof if you need to. So like I said, not that we won't do any, but I'm going to focus on the 2 columns because I think it's easier to follow. Here's an example. Okay, so this is kind of what you would be given up here, and this is what you would be expected to do. And of course, we haven't done them yet, so don't be alarmed. Okay, so this part is given in the book. This is the part you would do. Okay, Now, let me just kind of point out the areas that are easy to do. The given part, this part right here, is your very first step. Okay, so if you know what the given is, your very first statement is exactly the same. And guess what? Your reason? Given, because it's given to you. You don't have to have any other reason besides given there. Okay, so this is actually your reason, but that's only on the things that are written into that given. You're going to have some statements that follow. We don't know what those are yet. And then the ending step, I'll change colors for this one. This part right here is your very last statement. And that one does have a reason. It is not proof there or prove there. You have to come up with some other reason. So you might want to jot down that or else do a couple of examples that we're going to do just so you know today, this is what I want you to know. How do you start? How do you finish? We're going to fill in some things in between, and they might be easy today, they might not be, but that's kind of how you start. They're going to sometimes give you a picture. If they don't give you a picture, you might want to draw one yourself if they describe it well enough. And then you're going to have some things in between that follow. So the first statement's usually the given. You're going to have some things in the middle that follows. And the last step is whatever your proof statement is. Okay, so let's actually do one so that you can kind of see what it looks like. What is the value of x? Justify each step. So this one, they gave us a picture. I'm going to also put it up here on the board just because I won't be able to see it. Okay. Okay, so I kind of did everything that we are looking at here, and we're going to put this into this box. Now, for an algebraic proof, you would have all the boxes given to you. You would have to fill in every single one. Okay, so at least if I gave you something like this, you would know, okay, I have to fill in every single box. If I don't have every single box filled in, you probably forgot something. Okay, so here's kind of how you start. The first statement is always the given. So I'm going to go back here and I'm going to copy this exactly how it is into the very first line. Okay, so angle AOM and angle MOC are supplementary. Given. When I was sitting where you guys were, that's the only part I felt that I knew how to do. Okay, so don't feel like you don't know anything, because honestly, that's the only thing that I knew when I did these. So it takes a lot of practice to get good at these. Now, of course, I've had mucho grande practice, but when I was sitting where you were and they'd introduce proofs, I had no idea what I was doing. So don't feel bad. It takes time to get to know what to do. Now, we also know what the last thing is. The last step should be x equals 50. We're going to put that in the first column at the very bottom. So if we get to the bottom and we don't hit x equals 50, we did something wrong. Okay? Now, is there a way that you can get the last step right and some of the middle stuff wrong? Yes. If you don't know how to go back and fix it so that x equals 50, you're going to get that last step right, and maybe there's something small that you did in the middle to make it not right. So now is where we need to fill in everything else. We don't know the reason for that last step yet, but we're going to figure it out once we get there. Now, when you're doing this one, what does it mean that these are supplementary? What does supplementary mean? equals 180. So we're going to use definitions in here. So I said whenever you have a vocab word in the given, usually the next step after that is definition of that vocab word. So my reason for the next one is going to be definition of supplementary angles. Okay, so notice how this and this are basically the same. They're a definition. Now, Lexi said that they equal 180. So the measure of angle, this is going to be weird at how I write it, AOM plus the measure of angle, MOC, is going to be equal to 180 degrees. I don't count it wrong if you don't have the degree symbol there. But what that's doing is that's giving us some place to start. We have some sort of an equation. Now we can do things with it. Now, what does this little m mean? That means the measure of angle AOM. Instead of just angle AOM, the angle AOM is just looking at what is it in the picture. The measure of it's actually going to look at what is it in the picture. And now we're going to go to there. Now, with this one, this must have been O at the beginning, was it? Yeah, it was O. I just didn't write it in there. So this is O right here. So AOM is 2x plus 30. I'm going to substitute that in. So I'm going to put a 2x plus 30 in place of that one. Plus measure of, what's measure of MOC? X. I'm going to put that in there. And what do? We substituted those two values in. Substitution can be used anywhere, so I'm not going to put an equals there. If you want to throw in equals, it's fine. Now, what happens is it went from a geometric proof that used letters to an algebraic proof that used letters. We know how to do the algebra stuff, right? First thing we do is put like terms together. Now, this is kind of just getting used to how it kind of comes together. 2x plus 1x would be 3x. Now, what is it called when we put things together? It is not addition property unless you add to both sides. When you're just putting like terms together, it is substitution once again. In place of the 2x plus x, we are putting a 3x in there. Okay, so I'm going to jot a little note on the side because that is something that's hard to remember, but once you get it, it works. So let's see, let's put putting like terms together.
Where did you get 3x from?
I did 2x plus 1x, these two.
Oh.
Putting like terms together equals substitution. Putting like terms together does not mean addition property. Addition property means doing something to both sides. We have only done something to one side on this one. So basically, that's what I'm doing there. Now, if you were solving, what would you do to 3x plus 30 equals 180? What would you do on that? Subtract 30. Now, this is the part that some books do differently. If you need to show the subtract 30, you would put subtraction property of equality. We're just in the point where we can just do it, can't we? Most of us can just go, yes, I want to subtract 30 from both sides. So I'm going to put 3x equals 150. So it's kind of like you're just doing it. And I'm going to put subtraction property. Notice how substitution has an ST in there and subtraction has a TR in there. Do not do SUB for both of those. I need to see the difference. Okay, substitution, if you're not sure, write the whole word out, but make sure that you're looking at the ST for substitution and the TR for subtraction. Even if there's a T in for subtraction, I know which one it is. And what did they do to get from 3x equals 150 to x equals 50? divided by 3. So that would be division property, and you would do that to both sides. So division property of equality. So what I'm telling you is, if you know how to do all of the left side, do it. The right side will come. You're going to just do as much as you possibly can. A lot of times your last reason in algebra is division. Okay, so that's a common one. You could guess if you wanted, but you may not get all of them. Okay, anytime you're only doing something to one side and you're putting like terms together, that's substitution. So this one will be a common one as well. Your equations solve very similarly as you go. So let's look at another one. Okay, what's the value of x? Justify each step. So with this one, I'm just going to kind of go with it from here. I would probably jot this one down too, just so you have a second example. You guys will have a quiz on, I think it's Wednesday. So at least if you have a couple of examples, you'll go, oh, I think this one is kind of like this one. I can maybe use it to look. I would definitely draw the picture out in the given. It looks like I forgot the proof part. I will put that in there. So I'll give you a minute to copy that first part down. Okay, they didn't give us the proof part, but we can figure it out. This was a got it question. Anytime you guys are given something in the picture that isn't in the given, it's going to be a substitution thing. So eventually, we're going to plug those things that are in red into our proof. Statement column is always on the left. Reason column is always on the right. If you don't have a reason, you're not supposed to be able to write it down, but just so you know that that's kind of the style. So my first step is going to be AB, ray AB, bisects, angle RAN. Always given. There's just rare occasions where they start with something else other than given, but that's generally your first step. Everybody, even after today, should get step number 1 right. Now, usually they have a proof statement, so you could go directly to the bottom and put that in. They didn't do that on this one, but for all the ones that you guys will have to do, I will always have it there for you. We're going to actually figure out what it is in a minute. So this time, notice there's a vocab word in the given. If you don't know where to go, think about what bisect means. What does it mean? Cuts it in half. Okay, so if it cuts it in half, wouldn't those two parts be the same? So I'm going to say definition, angle bisector. I'd probably give it to you if you did definition of bisect. I'm going to say angle. Let's go. I don't know how many spaces I have. Okay. Don't write this one down. Okay, I'm going to do... I'm looking ahead to see how much room I have. I'm going to say angle RAB is congruent to angle BAN. Notice how on this one I have a congruent in the middle. On the last one we had measures of angles because that's what was given. We might have to add a box to the end. I wanted to show you the step today. Basically, we don't have numbers in there yet, and we can't plug any numbers in until we don't have a congruent symbol in there. Okay, so the next one, the main thing that I want to get rid of is this congruent symbol. and it's going to be definition of congruent. Again, a definition. You will use this one a lot. And I'm just going to use the symbol. What it means is if angle RAB is congruent to BAN, aren't their measures the same? So I'm going to put an M ahead and equals in the middle for both sides there. So I'm going to put an M ahead of the angle RAB and the BAN. And it's definition of congruent. Now that we have an equals in there, we can do all of the properties that we've written down today. So I'm going to go back up. In for the RAB, I'm going to plug in an X. And in for the 2X minus, or in for the BAN, I'm going to put 2X minus 75. Substitution. So whenever you take those values from the picture and plug them in, it is substitution property. And you can put an equal there if you want. I wouldn't count it wrong for substitution. Now, we're going to probably have to add one line underneath. That's okay. What would you do if you were trying to solve for x? Plus 75. I'm going to do the other way. Usually they leave the variable on the left, the numbers on the right. So if you had to get to an x equals, let's leave it. But you could do that. You would just have a different number of steps. Okay. So I'm going to subtract 2x from both sides. So negative x, oops, moved a little bit. And then how do I get rid of those negatives? Divide. So I'm going to divide by -1. So it makes it x equals 75. And I'm going to say, and could you multiply on that step too? Multiply by -1 or divide, either one. And I'm going to put or multiplication property. Now, when I added a line at the bottom, it changed the layout. When you guys are doing these, maybe like Kaylee said, let's add 75 to both sides. Would that be wrong? No. Eventually, she would have to get to an x equals 75. Maybe that's the way she's going to do it. It's okay. So she could have done addition property for adding 75. She would then have to subtract x from both sides, and then the x would be on the wrong side. How do you flip it over again? What property is that? Symmetric. She would have to use a symmetric property at the end to get that x on the left side. Doesn't matter that she did it different than me, as long as you're doing the right steps for how you're figuring it out, it works. Maybe somebody sees something that somebody else doesn't. It's okay. You just have to get all the steps in there, okay? Now let me see what else we have. I might stop right there. I think we have learned all that we really need to do these. And then I'm going to talk a little bit more about this last one tomorrow, just because we only have about 8 minutes left. So I'm going to hand out this worksheet, and you guys can probably do all your work on here. It's kind of filling in all the boxes with question marks in them. And some of them you might be able to see, and when you guys get this, I'm going to show you some tricks that I have learned over the years. Just because you don't know the second step doesn't mean you don't know the third step or the fourth one. So there are some tricks that you can use. Now, last year, the biggest issue was, how do I know where to put the step? Okay, for instance, When you look at, for instance, number 1, 0.25x plus 2x plus 12 equals 39, how do they go from step 1 to step 2? Where it changes, that's where you put the property or whatever you're talking about. So what did they do to that first line to turn it into the second one? What did they do? They put like terms together. Is that addition property or substitution? Substitution, because they didn't do it to both sides. Okay, so for A, substitution property. Even though they added the amounts, they didn't do it to both sides. That makes it not addition property of equality. So part A, substitution, just write it next to it. I'm gonna skip around a little bit. On number 2, how did they go from step B to step C? What did they do? When they look at 9x equals 72, and how did they get to x equals 8? Division. So on 2C, division. Notice how I didn't even look at the beginning part of the problem. If you know how they went from B to C, the step goes in C. Look at go to the back side, number 9. What is step 1 reason? Generally always given, write it next to it. So on the back, number 9, number 1 is given. Easiest step to get right. How do they go from something that has words in it to something that's equational? From step 1 to step 2 on the back side? Definition of the vocab word, right? It has a vocab word that says complementary, so step number 2 must be definition of complementary. Okay, so anytime you see a vocab word in the given, the next step is probably definition of that vocab word. Okay, and that's just kind of a habit you got to get into. Let's see, what else can I point out? Step 5 on the next one is probably going to be your hardest one. If you have a question on that, ask tomorrow. I just want to see if people can get it. And then when you get to number 11, I will do this one right away at the beginning because I'll tell you how many steps it has. So what I really want you to do for tomorrow is 1 through 10. We will finish number 11 right away at the beginning, okay? If you want to try number 11 just to see if you get it, just because I use a certain number of steps doesn't mean that you might not have something different. So it's okay. So 11, I'm going to say for now is optional, but tomorrow we'll do it for sure. Okay, and maybe we'll do that one together. So 1 through 10 for sure. 11 we will either fill in or you can try it on your own.